Today we're looking at 5.6 parallel and perpendicular lines. Our goal for today is to determine whether lines are parallel, perpendicular, or neither, and to write equations of parallel and perpendicular lines. So the first thing we need to understand is what it means to be parallel. So parallel lines never intersect. So if you look at the graph here, this is a graph of two parallel lines. If you notice, their y-intercepts are different, but their slopes are the same. This one I'm going up 1 over 2. This one I'm going up 1 over 2. So parallel lines have the same slopes. So let's just use the fact that parallel lines have the same slopes in an example. So example 1, it's writing an equation of a parallel line. So this is the same idea that we've been doing. It says a line passes through 12, 5 and is parallel to the graph y equals 2/3 x minus 1. What equation represents the line in slope-intercept form? So what information we're given is that my line passes through this ordered pair, 12, 5, and it's parallel to this line. Remember, parallel means that they have the same slope. So if this line has a slope of 2/3, remember slope is always the number in front of your x, then my line should also have a slope of 2/3. So my m is 2 over 3. The only thing we get from this equation right here is the slope. You don't use anything else from it. So the only important piece of information here is the 2/3. Everything else you ignore. Once I have my slope and my point, I'm going to write it in point-slope form. So I would do y minus y1, so my y1 is 5, equals the slope times x minus x1, and my x1 is 12. Now this is just like every other problem we've done. I'm going to distribute 2/3, so this is y minus 5 equals 2/3 x. 2/3 times negative 12 is negative 8. Then I'm going to solve for y by adding 5. Negative 8 plus 5 is negative 3. So I have y equals 2/3 x minus 3. And that is my equation of my line. So let's try one more of these. A line passes through negative 3, negative 1, and is parallel to the graph of y equals 2x plus 3. So since it's parallel to this graph, it means they have the same slope. So if the slope of this line is 2, the slope of my line is also 2. Since I have a slope and a point, I'm now going to write it in point-slope form. So I have y minus my y1, so minus negative 1, equals the slope times x minus x1, and my x1 is negative 3. Remember, minus negatives make plus positives, so I'm going to switch those. And now I'm going to solve for y. So I have y plus 1 equals 2 times x is 2x, 2 times 3 is 6. Now I'm going to minus 1 on both sides, and I get y equals 2x plus 5. And there's my answer. So that would be writing equations of parallel lines. Now let's look at perpendicular lines. Perpendicular lines are lines that intersect at a 90-degree angle. Now what we need to know is that if they intersect at a 90-degree angle, the product of their slopes is -1. Now, an easier way to remember this is that perpendicular lines have opposite reciprocal slopes. Now, opposite means different sign, so switch the sign. Reciprocal means flip your fraction. So for example, if I have a slope of -1/3, the opposite reciprocal of that would be +3/1. So I used the opposite sign and I flipped my fraction. So just like if I started with a whole number, say my original slope was 4, the opposite reciprocal of that would be -1/4. Because remember, 4 as a fraction is 4/1. So I have opposite signs, and I flipped my fraction. So let's use this with an example. This one says the line passes through 4, -1. So I have a point for -1, and is perpendicular to y equals 1/3 x plus 2. Since it says perpendicular, they do not have the same slope. Since the slope of this line is 1/3, my slope is the opposite reciprocal of that. So remember, perpendicular lines have opposite reciprocal slopes. So since this is a +1/3, the opposite would be a negative. The reciprocal would be 3/1. So my slope is -3/1, which just simplifies to -3. So now I have a slope and a point. I can write it in point-slope form. Y minus -1 equals -3 times x minus 4. Minus -1 makes a plus +1. So now I solve for y. I distribute -3, so I have -3x. -3 times -4 is a +12. And then I minus 1 on both sides. So I get y equals -3x plus 11. So that is how you write equations of perpendicular lines. Now, what if we already have equations of lines and we want to see whether or not they are parallel, perpendicular, or neither? So that's the next example. The first thing you need to make sure you do is look to see if they're in slope-intercept form. So the first thing is all of these need to be in y equals mx plus b form, because we don't know the slope if it's not in slope-intercept form. So number one, this one is not in slope-intercept form yet because the y isn't alone. So I'm going to divide every term by 4 to get the y alone. So this is y equals -5 divided by 4 doesn't go in evenly, so it's just -5/4 x. 12 divided by 4 is +3. The other equation is already in slope-intercept form. So, what I'm going to do to see if the line is perpendicular, parallel, or neither is I look at the slopes. I have -5/4 and I have +4/5. If they were parallel, they would be the same slope. So these are not parallel. If they were perpendicular, they would be opposite reciprocals. Well, -5/4, the opposite would be positive. The reciprocal would mean I would flip my fraction. So the opposite reciprocal of -5/4 is +4/5. Since my other slope is +4/5, these are opposite reciprocals. So my lines are perpendicular. So let's look at number 2. Again, this one is an in-slope-intercept form because there's a 6 in front of the y. This is 6 times y, so I'm going to get rid of it by dividing every term by 6. 6 divided by 6 is 1y. Be careful, -1 divided by 6 is not -6. It is -1/6. And now 6 divided by 6 is 1. Now the other equation is already in slope-intercept form. So again, if I want to check to see if they're perpendicular, parallel, or neither, I just look at their slopes. This line has a slope of -1/6. This line has a slope of -1/6. Since their slopes are the same, they are parallel. This was a lesson for 5.6. Make sure you fill out the Google form, and I hope you guys have a nice Thanksgiving.